to 0, 0, 0, 0. Very good. Times 1 plus r over 4 to which power?
19.
Awesome. Don't forget times the inner function prime. Times the inner function prime. Can anyone give us the derivative of this function? The inner function prime. And I will write it here. Great job. Thank you. The derivative of this function times the inner function prime times the inner function prime. What do I write? Will anyone give us the derivative of this function, please? What is the derivative of 1?
0.
Excellent. What is the derivative of r over 4? You may have said it correctly, but I just didn't hear it. I know everyone knows the derivative of r over 4. What should I write, please? What do you think? It's okay. What do you think? The derivative of r over 4 is?
4.
So r over 4 is the same with 1/4 times r. Can anyone differentiate this for us? How much? If I have 3r, what is 3r prime?
1/3r.
But why would I change 3 into...
Oh.
Why would I change 3 into 1/3? I just want to differentiate. How much?
3.
Awesome. What will be the derivative of this then?
4.
Say it again.
4.
But if 3r prime is 3, why 1/4 r should be 4? Why?
Is it just 1/4?
That's it. Thank you very much. It is 1/4. Great job. So then 20,000, because this is a product, 20,000 divided by 4 is 5,000. And then times 1 plus r over 4 to the 19th power. This is it. This is the derivative of the accumulated with respect to the rate. Accumulated amount with respect to rate. This is it. So now the question where we are asked also is to find the
Where
rate.
does the 5,000 come from?
20,000 divided by 1/4 is 5,000.
Okay.
Perfect.
And what about the 1/4r? Is that the derivative of r over 4?
Yes.
Oh, what is it?
So
Okay.
I was showing that r over 4 is the same because it's easier to understand how to get this, right? So r over 4 is the same with 1/4 times r. So by analogy or comparison, I want you to understand that r over 4 prime will be 1/4. 3r prime is 3. So we're asked to find the measurement unit. Remember, this is in percent. It's the rate. This is in dollars. What will be the measurement unit for the rate of change of the accumulated value with respect to the interest rate? So measurement unit. What would be the measurement unit for dA over dR? What would be the measurement unit for the rate of change? We know that the accumulated value is measured in dollars and the rate is measured in percent. So what would be the measurement unit for this? What do you think? Give me what you think. Anything, please.
The percentage.
So the measurement unit has to have, for the rate of change, has to have two measurement units. One coming from the numerator and one coming from the denominator. Always the average rate of change, the derivative, the instantaneous rate of change, all of them have to have two measurement units. So what will be the measurement unit for dA over dR?
Dollars or percentage.
So dollars per percent. Exactly. This comes from here, this comes from here. Awesome. We're also asked to explain what this means. So what does A prime of R mean? What is the explanation? Why do I even look at it? So again, this is the rate of change of accumulated value with respect to, lazy people write with respect to like this. I'm kidding. That's the abbreviation, with respect to interest rate. I should say annual interest rate. So that's what it is. That's what it means. So A prime of R is the rate of change of the accumulated value with respect to annual interest rate. If it's positive, it's positive. If it's negative, it's negative. But obviously, in this case, it should be positive. Okay, perfect. I would like to discuss the very last section, and then we'll continue with more problems. The last section of this chapter is 1.8.
I'm sorry. What
Yes.
does accumulated value? What does that mean? WRT.
With respect to
Okay.
the
Okay.
annual interest rate.
Okay. You good?
So this is the formula that we looked at a long time ago. R over N raised to NT. The accumulated value is, let's say, in 10 years from now, if we put in a certain principal into a bank account at a certain interest rate compounded N times per year for 10 years, the accumulated value is what we get in 10 years. Okay, so 1.8, is that okay? Is that what you had in mind?
Yes, thank you.
Thank you. So 1.8, higher order derivatives. What is this? Well, so far we know f prime. Well, higher order means the second derivative, or the third derivative, or the fourth derivative. If it's higher, then after a while, we will use parentheses for the power and put n. It can be the 10th derivative, the 11th derivative, the 20th derivative. So the first few, we use Roman letters, first, second, third, fourth, but after a while, we use just n. We're not going to go beyond the first three derivatives at the most. Nothing to teach you here, just to find what we need. I'm going to change that page into 179. All the rules stay. We're just determining the second, and you'll see the application of the second derivative later. Okay, so the notation, so let me stop for a second. We know that this is the same with dy over dx. This, the second derivative of y with respect to x twice. d2y over dx2, and so on and so forth. d3y over dx3. And as I said, so on and so forth. This is this is this, and so on. So don't get scared about this notation. It's just a different notation. So let's choose from here. It's the same thing with the second derivative. Anything you want from 1 through the word problems, through 34. Which one would you like to work on? If not, I will choose. Okay, I want to choose 31. 31 on page 179 has y equals x to the 6th minus x to the 3rd plus 2x. And they want us to find the fifth derivative. Okay, fine. So first we have to find dy over dx, then d2y over dx2, then d3y over dx3, then d4y over dx4, and d5y over dx5. 1, 2, 3, 4, 5. So let's find the first one. Can anyone give us dy over dx? Can anyone differentiate this with respect to x, please? Anyone?
6x to the 5th
Awesome.
minus 3x to the 2nd plus 2.
Awesome. Done. We are differentiating now to find d2y over dx2. Anyone, please?
$30x to the 4th minus 6x.
Perfect. This is done. d3y over dx3. Can anyone differentiate this? Next. Please give it a try.
120x
Yes.
to the 3rd
Yes.
minus 6.
Awesome. So this is done. Now I want d4y over dx4. Can anyone differentiate this again?
$360x
To which power?
to the 2nd.
Excellent. So this is done. Last one.
$720x.
That's it. So we went through all these steps to find the fifth derivative, and here it is. These are the useful ones, the first and the second, and you'll see applications of both later. Let's look at a word problem. So let's start with 37. And I think I'm on page 7. I need to make sure that they're in the correct order, so when I scan them, I don't torture you. You don't have to put them yourself. So 37 on 179. They're given a distance function, s of t equals t squared minus 1/2 t plus 3. So the distance is in meters, and t is in seconds. Fine. Find each of the following. They want us to find the velocity. They want us to find the acceleration. And then the velocity and acceleration when t equals 1. So v of 1 and a of 1. Awesome. So this is an application of a higher order derivatives. Okay, how do I determine the velocity? I have the distance function. How do I determine the velocity, and what does the velocity represent? What is it? How do I determine the velocity? The velocity is the derivative of the distance function. The velocity is the rate of change of the distance with respect to time. That's why the velocity is s prime. Can anyone differentiate s of t so we can find the velocity? Anyone, please? I know everyone knows how to differentiate this. Anyone I haven't heard from today, please.
2t.
Yes. Minus
2.
so 2t minus
Is it just 1/2?
excellent. Brilliant. Very good. This is it. That's the velocity. What will be the measurement unit? I want to put the measurement unit of the velocity here.
Second.
So this is the rate of change
Mhm.
of distance with respect to time. It has to have two measurement units.
Like seconds over time.
It cannot be. It's the opposite. Awesome. Great job. Good. Now we want to find the acceleration. What is the acceleration? Is the second derivative of the distance or the first derivative of the velocity? Can anyone differentiate this? And we will write the answer. What is the derivative of this function? Because the second derivative is the derivative, the first derivative of the velocity. So what is the derivative of this? Can anyone give us the derivative of 2t minus 1/2, please?
2.
Excellent. We also have to discover the measurement unit. They cannot be the same. The acceleration cannot be measured in meters per second. The velocity is measured in meters per second. So what is the velocity? Is the rate of change of velocity with respect to time. So these two cannot be the same. Can anyone give us the measurement unit for the acceleration? Anyone, please? Okay, acceleration is measured in meters per second squared. So please understand the velocity is measured, in this case, meters per second, and the acceleration is measured in meters per second squared. Now, can anyone plug in 1 here and tell us what we get? Because when you plug in 1 here, you also get 2. So this is 2 meters per second squared. There is nothing else. But can anyone plug in 1 here and tell us what to write? And the measurement unit will be meters per second. So when we plug in 1, 2 minus 1/2 is what? 2 minus 1/2 is?
1.5.
So So we have 4 minus 1, 3/2. 1.5 is fine. Good. Any questions? Okay, so let's work on